6.1 is linear algebra. And again, between me sort of explaining this when we did chapter 4 and you having seen it in grade 8, I think you're going to find that this first part will feel like review. In fact, let's start with this. If it says solve and check, we're basically trying to get the x by itself. And algebra is all about opposites. You're going to hear me saying that over and over again. So if we're trying to get this x by itself, what would be my first move, or maybe my only move in this case? Yeah, Brendan?
So basically, you need to move equals over, so you can sort of rephrase it into 2 minus 3 equals x.
Okay, so we leave the equal sign there, but you're right. We want to move the 3 over to the other side, which is what you were saying. So the opposite of plus 3 would be minus 3, which we're going to do on both sides. And I feel like a lot of this is organization. So let's get into good habits of how to show our steps or how to work our way through this. So on the left side, after doing this, I only have an x there. And on the right side, what is 2 minus 3? Negative 1. Does that make sense? And then notice how, so it says solve, we did that, we said x is negative 1. And how do you think that we check this? It's saying solve and check. How do you check it? Yeah. Good. We plug in negative 1 into the equation. So instead of x here, I'm going to plug in that negative 1. Actually, I'll color code it even. Let's do negative 1 there that we just found. And then we do plus 3, and that should equal 2 if we've done the right thing. So what is negative 1 plus 3? It is 2. So we end up getting 2 equals 2. That's the way that we show that we're checking it. Good? You can probably do that in your head. You didn't need to write it down, but if the question says solve and check, then yes, you need to show that you're able to understand and show how to check this. Okay, so am I right that this is review? Do you feel like you've seen that stuff before? Okay, you know how this works. We add in something a little bit different just to get a sense of what this would be like. So we're dealing with some more negatives, but it's still the same thing that we're doing. If you want, you can just call it out because we just finished doing this. But in this case, if we're wanting to get x by itself, algebra is all about opposites. So what do I need to do on the left side of the equation? Plus 5. We do the opposite. Algebra is all about opposites. An equation is like a scale. We have to keep both sides balanced. So if I'm adding 5 there, I also have to add 5 there. So you can think of that like have you seen one of those scales that tip from side to side? You know what I'm talking about? Okay, so then after doing that, on the left side, again, minus 5 plus 5 just cancels. So x is equal to, what's negative 2 plus 5? It's just 3. And if we were going to check that, that means here I'd plug in my 3. So I'd have 3 minus 5 should give me negative 2. And it is negative 2. So that's how I check it to know that I've done this right. So far, so good? Feels like review? I feel like every class I say that this feels like review. And does it feel true? So basically you've learned nothing in the whole course? Okay, let's take a look at something a little bit different. Let's say we have x over 4 and that is equal to 5. So we're still using the same principle. Algebra is all about opposites. If we're looking to solve it, we're trying to get x by itself. So in this case, what would I do to get x by itself? What is the opposite of the operation that's going on here? Times 4. Everybody good with that? So this would be multiplying by 4. This would be multiplying by 4. The reason we did it is so that it cancels. So x is just equal to 20. This time we won't actually plug it in to check it. We can just do it by looking at it. If I were to plug in 20, what's 20 divided by 4? It's equal to 5. That's what we have in the original question. So we know that we've done this right so far. Are there any questions so far? Okay, you know how this works. We're keeping it pretty basic to start off with, but then we're going to start adding things in and putting it all together. But I think taking this step-by-step approach is a nice way to go through it. So let's say we have 4x equals 64. At this point, you can just tell me, what should I do? Yep.
You divide each side by 4 and then you get 16.
Good. These are divided, so x is equal to, we get 16 when we divide it out. So those are just the single step equations, and it seems like we've mastered those and perhaps didn't even really need to do them. So let's up this a level. Let's say I have negative 2x divided by 3, and that is equal to negative 6. I'm going to give you a minute. I didn't show you how to do this, but we did do the one step without me even showing you. Can you figure out how to do 2 steps? Or where there's more than one operation going on? And I would suggest breaking it down into a step-by-step method to split up that negative 2 over 3. If we want to get x by itself, and I want to break this down step by step, what's the first thing I should get rid of? The 3. What is the opposite of what you see happening with the 3? Multiply both sides by 3. Because does everybody see that we're dividing by 3 on the left side? The opposite of that is multiplying by 3. The reason we did it, look at that, it cancels. So I'd get negative 2x equals, what do I get on the right side? Negative 18. And then our next step, I want x by itself. What is going on here between the negative 2 and the x? Yeah, they're being multiplied. So how do I get rid of the negative 2? Divide both sides by negative 2. That gets rid of the stuff on the left side and leaves us with x equals positive 9. Everybody good with the reason that it's positive? If you have a negative over a negative, it cancels out and gives us a positive. It didn't say solve and check. We were just solving this, but if it did, I would just take this 9, plug it back into the original question, right? And we could work our way through it just mentally. 9 times negative 2, and then dividing that by 3, does that give us negative 6? It does. So you can always just check it on your own. So the truth is, for this stuff, you don't really even need me to mark it for you. You could check it yourself to see if you've gotten it right. Good? Okay, and then you know how this goes. Let's add in another step. So 5x minus 4 equals 2x minus 1. Okay, let's compare it to what we just did. And you can see how now there's even a little bit more going on. So if you're thinking of like things getting harder, it doesn't actually get, well, maybe what we consider to be harder is just, it gets a little bit longer and we have to put in more work and do more steps to sort of simplify and break it down. So if you have an x on the left and the right side, what do you think we need to do? Because we're trying to solve this. Get them on one side. Does that make sense to everybody? So if we take a look at it, remember how we look for like terms? These two are like terms. Our first step is get the like terms together, and then these are also like terms. So we need to move things around. So does it make sense for me to move the 5x to the right or the 2x to the left? 2x to the left. It's not going to be wrong if you do it the other way around, but do you see we'll end up with a negative the other way around? So you can be smart about what you're going to choose to do with this, but know that the other way wouldn't be wrong. You would just have a little more work to do to simplify that afterwards. So how do I move the 2x to the other side? You know how algebra is all about opposites? How do I take that whole stuck together unit or term and move it to the left side? Yeah. We subtract 2x because we treat it like a stuck together clump. And so we're subtracting 2x on both sides. So do you see the reason we did it on the right side is because it's gone and I'm left with -1. What is 5x minus 2x on the left side? That leaves us with 3x minus 4. Good? And then how do I get rid of the -4? I'm trying to get x by itself, so what would be the next move here? Plus 4 here, plus 4 here. And so the reason we did that is to get rid of this. 3x equals, what do I get on the right side? +3. And then my next move, if I want x by itself, would be, I just want x by itself here. Divide this by 3, which means I better divide that by 3, which cancels. So what's x after all that hard work? X is just equal to 1 after all of that. Let's plug it in and check to see if that actually makes sense. So 5 times 1 minus 4 should equal 2 times 1 minus 1. So what do we get on the left side here? 5 minus 4 is 1, and 2 minus 1 is 1. So it worked when we check it. Good? So do you see that in, like, this is, I guess, the longest or most difficult one that we've done so far, but do you see it's actually the same initial steps that we were doing? It's just all packed into one question. So if you look at it that way, it doesn't feel so difficult, and it's a little bit easier to manage. Okay, let's do one more, and then I'm going to give you some questions to practice with. Okay, let's say we have -2x minus 1 equals, oh, no, let's make it more exciting. Let's make it -2/5x. And I'm going to give you a minute. I'd like for you to think your way through and try that on your own. A little bit more going on, but if you take that step-by-step approach, I think you'll find it's not too bad. So I'll give you a minute and then we will go through it together. So give it a try. Done? If we want to get x by itself, what's the first move? What do we get rid of first? The -1. So we're going to add 1 on both sides. Everybody good with that? As a rule, the part that's clumped up with the x, like the 2/5, you leave that part till the end. You start from the outside to get rid of things and work your way in towards the x. So use that as a rule. So we would have -2/5x, and this would be gone, equals 4 plus 1. So we would just get 5 there. So far, so good? Let's do this step by step. We could do it all in one shot by dividing by this whole fraction, but that's going to get messy and complicated. I like the step-by-step method. So what could I do next to do the step-by-step method? What can I get rid of next here? The 5, and how would I get rid of the 5 at the bottom here? Multiply this by 5, which means I also have to multiply this by 5. Everybody good with why we're doing that? The reason we're doing that is if you have 5 divided by 5, do you see it cancels to just leave us with a 1? And 1 times -2 would just be -2x. And on the right side, we have 5 times 5. So we get 25. So far, so good? And then we want x by itself, so what would be the next move here to get x by itself? Divide by -2. So we're going to do that on both sides. which cancels this here. So x equals, do you see that this would be either negative 25 over 2? I just want to clear this up for you. That is the same thing as saying, like I've put the negative sign at the top. If I had the negative sign in front and then I just had a fraction like negative 25 over 2, or if I put the negative sign at the bottom, they all mean the same thing. Does that make sense? The key is you only have one negative sign there, right? So in a fraction, it doesn't matter where you put the negative. The other thing is, I don't really like this. This is an improper fraction. What's another way that I could give my answer to this? What's a better way? What do we do with improper fractions? SD. Sorry? Mixed number. Yeah. So what would this be as a mixed number? Do we know? Yeah. 8.5? Yeah, so we want to look at this and say, okay, how many times does 2 go into 25? Right? And do we see that it's 12? Because 12 times 2 is 24. The denominator stays the same, which is this here. I should color code this. So this stays the same. And then I go, okay, 12 times 2 is 24, but I have 25 here, so I have a 1 left at the top. My color coding is really not working today. And it's a negative. Oh boy. What a way to end things off. Oh, there. Okay, so I would say this is the best way to give the answer. If you write down negative 25 over 2, that's not wrong. It's still right. But let's get into good habits to work with. And your work for today for 6.1 is 2 to 5 and 8 to 10. I'd like you to do all of them.